Alright, so today we're going to correct the EDA that you sent me, and I guess we'll also add a digital elevation model in here and change the symbology so that it's easier to visually analyze. So go to layer, we'll add a raster layer, and we'll navigate to the raster that I sent you there. Volunteer projects, Sedley, JS files, rasters, the clip of the DEM. So we'll add that in here, and it's just going to be black and white. So if we turn on your EDA there, we can see it's in there vaguely somewhere. But if we go to properties here, we can go and do single band pseudo color, and go to the color ramp and click create new color ramp. Go to CPT city, click OK, and head on down to topography. This is the one that I like to use. You'll see it's continuous colors, and hit OK. And so now if you click apply, it'll show up, but then it still is it's actually even worse to really look at. So you gotta do this. You gotta go equal interval, make like 150 classes, and then go back to continuous and click apply. There. So now you can kind of see a little more detail. Zooming out. So we can see the high point is this ridge, and this is the low point. So unfortunately our clip has actually taken in a little piece of the Coppell Valley, so that kind of skews things a little bit. So I actually probably don't want that. Let's do, oops, no, I don't want that. Clip. Nope, wrong clip. Clip raster by extent. Clipping extent. Use the canvas extent. Assign specified no data value. And we're going to put this right beside the original. Yep, so we're in rasters. Clipped East Regina. V2, I guess. Alright. Click run. These things go pretty quick. We're going to remove the original one. We're going to do the same thing to this one. Pseudo color. New color ramp. Okay. There, so now you can actually, this really tells you the terrain that you're in. You're in this is the Chrono Marsh, and then this is the hills of Wascana Creek up here, I guess. And then this is the other side of Wascana. No, that's the upper Cirrus. So this here is also Wascana Creek. It comes and it bends back around. So there's a little hill here, and so the Wascana Creek actually makes a giant U shape and then comes back in. So let's turn on our thing here. So hopefully with this we can kind of see a little better what we're looking at. So this is, let me just change the symbology of this. Okay. Yeah. So this is the purported, I suppose you could call it the incremental drainage areas, but these are actually the ones that Walkwater has created, and I emailed them to you a while back. Well, I think I just emailed you the combination of this one, yeah, this one, and this one. Except I clipped this one to where our wetland was, which is here. So there's like a little bit coming out here. So we basically got water coming from 3 sub watersheds. Sub of that. So yeah, your effective drainage area is like 5% of the gross drainage area. So I'll just go over with you how I would do it, I guess. So I will create a new layer, and I'm going to make it a shapefile just for interoperability. And JS files, shapefiles, and we'll call this Sedley Sedley V1. I suppose it would be V2 since you already created V1. That's the datum that we'll keep. No fields. Okay. Oh, whoops, I made a point. I got it. I'll delete that later. But new shapefile, and we want it to be polygon. Okay. Yes. There we go. Alright, and then we'll change the symbology of this of like this maybe. And then the outline, change it. Oof. One point. All right. So I'm just gonna go ahead and add a group and be like, call this other. I don't know. I'm just taking things that I don't really need at the moment and throwing them in there. I'll keep the base maps, and this guy could go in there as well. There, so now I should only have things that I really need. Okay. So I think we've decided that we're only going to look at this area for volumes, because we determined that it'd be pretty tough to work this in a way that would get any significant volume of water. So I think we'll define our point of outlet to be the road here basically, and our EDA will be anything that makes it to the road. So let's do that. So here's the road, and now we just gotta decide what is effective and what is not. So looking up here, I can see this, and I'm not sure. The question comes, does this go across the road and down the field, or is there a culvert there, or is there not a culvert and it just runs down the road allowance? I suspect there's no culvert there. Actually, it looks like there is. Alright, so that's not even part of our gross drainage area. But I'll say it's about here. So I'm saying that anything here will contribute, will run down the field and end up in here in a 1 and 2 event. And I'm saying anything up here, it's true that it will run down, but it's more likely to just saturate into the soil in a 1 and 2 flood. And you have all these little tributaries here, and they're all running here, and then they're going down here into our wetland. So I'm going to say this goes here, and I can't see because of clouds, and well, that doesn't look very good either. And our DEM does not do anything. What did your DEM say? Your DEM didn't even come up here. Alright. Uh-oh. Okay. I can see these lines here too, actually, so maybe I should have kept going up. That's interesting. So I'm going really quick and dirty here. I'll clean this up a little more, like make it look a little more presentable than what it currently is. But I just don't want you to watch a 1,000,000-minute video. Oops. Interesting. So this is one of those tough scenarios where you actually have a stream that seems to go 2 different ways. It seems to go this way and around and this way and into our drainage area. And at some point you kind of literally have to draw the line. So I drew the line at the road and I said anything going over here is mostly going this way and everything over here is going mostly this way, although that's not entirely true. We're literally drawing lines in the sand. So you have to kind of compromise a little bit. So here you can kind of see the rationale for, I guess, how I am doing it compared to how you're doing it, or we're doing it there. Like, so this is a ditch, and without that ditch, none of this would be part of the contributing drainage area. But since they've dug a ditch, they've added to the contributing drainage area. And that's why drainage has been such an issue and a hot topic, is because these ditches are adding contributing drainage area one by one, and a seemingly insignificant ditch can add a lot to a watershed's contributing drainage area. So in the upper reaches of the watershed, I would keep the line between the effective drainage area and the channels a lot closer than at the bottom of the watershed. So things at the bottom of the watershed are going to have an easier time getting to the channel than the ones at the top. Like water up here will, yes, make it to the channel, but not at the same rate. Like water can make it to the channel, but it won't necessarily make it to the adequate outlet, if that makes any sense. Oh boy. I think I'm gonna have to fix that later. So I guess this here is an example how pollution ends up in the channel when you've got a gravel pit here directly contributing with no sort of filter into the main channel. Is it a tree line or a ditch? that's a tree line. Alright, well that's one stem done. Now off to the next one. Actually, I'm gonna go back. Walk back on that. Oh boy. Oh my god, this guy loves drainage. And here you see pasture land tends to not really have much in the way of drainage, and thus tends to have pretty small contributing drainage areas in comparison. No, I guess all this stuff's also contributing. Oh, it looks like it actually isn't. It's probably just going the other side. We'll see it is here. Damn, suddenly we are done-ish. I'd say it's working draft on this one, and then I would go back and look at it again, just straight up go through, look at what you've done, and slowly make corrections to it. Like, you know, things like this where obviously I was going down here and I quickly shot up, I'd smooth that out and things like that. So you should never just do one draft of something and call it a day. You can always use this tool here. For example, like down here, I guess I've got this one snapped here, but this one's not snapped here. I also actually have to change the snapping thing. Vertex and segment. So that would just bug me. Seeing that, there we go. And then you just go along. Turn off snapping. Add the vertices. Move along. Make it look nice. But I'd actually change this fill to something else. Stroke color. Deep dark blue. Fill color. More like that. Yeah, that's kind of easier to work with. So yeah, I'll fix this up and then I will send you the final copy.